All right, so once again, it was supposed to be 90 degrees clockwise or 270 degrees counterclockwise. Easiest one was to look at point A. What about this question right here? If triangle ABC were rotated 180 degrees, where will C prime be located? Well, this one right here, C is right here. What is 180-degree rotation? Okay, if I rotate, yeah, it's going to be this way. And I have to land over here because remember, it's going to be half the 360. So what you want to do is extend that line. And you're going to use your slope to kind of guide you to do so. So right here, I notice that I went up 4, 2, or you could say 2, 1. So if I continue the pattern, the only thing is that you want to make sure that it's equal distance to both sides. So if this one right here, I went up 4 and 2, you also have to continue the pattern. 4, wait, that's 3. But then 2 on this way because I want to basically make a line segment that again, the only way that it's going to be a line segment, that's going to be the 180 that we were kind of used to right here. And then I would say that these are the coordinates right here. So it would be C prime right here. What are these coordinates right here? Negative 2, comma, negative 4. Right. So that would be answering this question right here. C prime would be located at negative 2, negative 4. So be careful also with the 180 rotation. So notice how even the 90 or the 180 or even the 270 might require you to look at the slopes to help you answer these. Okay. On the 180, just ensure that the center point remains the midpoint of those. All right, let's look at now rotational symmetry. Rotational symmetry, it says some objects have rotational symmetry if a figure can be rotated less than 360 degrees about a point so that the image and the preimage are indistinguishable, then the figure has rotational symmetry. We're going to look at this ceiling fan first, and then we'll look at the star. All right, so this is what they mean. Here I have the ceiling fan right here, and rotational symmetry has to do with the following. If I take the center point, which is going to be the center of my drawing, and I'm going to make a line right here, and what I'm going to do is I'm actually going to rotate this figure, and notice how if I rotate it, and actually it's rotating a little bit off, but let's move it up a little bit over here. You're going to notice that it gives me back that same figure. Okay? So now my question is, I should have actually put a point on here. If I follow this point right here, let's say if I make a point right there, and actually it's not going to group them. Let me see if I can group these right here. We'll make a point here. Okay, that's what I want to do. Let me move back my figure. Alright, maybe I needed to indicate a point on that right there. So now let's go ahead and rotate it. If I rotate it and I go back to the same location, it kind of gives me back that figure right there. So my question is going to be how many degrees did I rotate it to find the rotational symmetry? Well, here's the point now where it was originally. How many degrees did I travel or did I rotate so that it gave me back that same figure? So how many degrees is this right here? 120. Good. How did you figure that out? Yeah, because if you notice, there are 3 sections that are equal distance, and I know that the complete revolution is 360, so it's a 360 divided by 3 is going to give me the 120 degrees. Okay. So on this one, when I go back to my notes, I would say that the rotational symmetry, because if I rotate this one right here, if I rotate it over here to this point, it's going to be indistinguishable. So the rotational symmetry is 120 degrees. What about this star right here? First of all, does it have rotational symmetry? And if it does, how many degrees is it? So go ahead and do that one. Think about it, and then we'll go over it.